Alright, you are welcome to this lesson, and in this video we have to use the quotient rule to solve this problem. And we did something similar to this in the last lesson, so let's go. So the formula says that if you have, I always love to do this, if you have a function in form of u of x all over v of x, we always remember that this v of x must not be equal to 0. Then the dy dx of this function will be equal to, the law says that you should keep the second function v of x and differentiate the first function u of x minus, do the reverse now, and keep the first function and differentiate the second function all over the square of the second function. That is what the quotient rule says. So if we can pick our u of x and our v of x, then we can safely compute the formula. So from this equation, it is obvious that u of x is equal to, according to this, e to the 5x squared plus 2, and u prime of x is equal to, we know the answer is 10x e to the 5x squared plus 2, and also v of x is equal to 2x squared minus 3, and also v prime of x is equal to 4x. So let us compute the quotient rule. Dy all over dx is equal to the v of x first, which is the second function, 2x squared minus 3 into u prime, and u prime is simply this, 10x e to the 5x squared plus 2 minus, now we keep the u of x now, which is this, e to the 5x squared plus 2, and we differentiate v of x, which we got to be 4x, all over the square of this man here, which is 2x squared minus 3, all squared. I hope you're following. So at the end we have the dy all over dx to be, we can simplify, or we can say this should multiply this. No, we don't have to. Here we can have 2x squared minus 3 into 10x e to the 5x squared plus 2 minus, can multiply this out to our 4x e to the 5x squared plus 2 all over 2x squared minus 3, then all squared. I think this is the result of differentiating that function, doing that function. So if you want, you can factor out e to the 5x squared plus 2 if you like, but if not, you can just simply stop here. But yes, you can just simply stop here. Thank you, and see you in the next lesson.